Hello and welcome to Learn Yourself. Today we are going to solve some of the questions from chapter number 2, Acid, Base and Salt. This chapter is from CBSE Standard 10 syllabus. In my previous video we have seen sub exercises and I have given that link in the description. So our sixth question is, compounds such as alcohol and glucose also contains hydrogen but are not categorized as acid. Describe an activity to prove that. So this whole topic we have discussed when we have learned the dissociation of acid and base and strength of acid and base. I have given the link of that video in the description. You can check this answer from there. So seventh question is, why does distilled water not conduct electricity whereas rain water does? First of all, what is distilled water? Distilled water is a pure form of water in which there are no minerals, no salt. And what is rainwater? Rainwater is full of mineral and full of salt. So when we are keeping the rainwater in the electrolytic cell, those salts will dissociate and it will give us ions which are responsible for the passage of electricity. Whereas in the distilled water there are no minerals or no salt. So if the ions will not be generated, then it cannot pass the electricity. So distilled water will not be utilized, or we cannot use distilled water where we want to conduct electricity. But when we are using a rainwater, then with the help of rainwater it can pass electricity and rainwater can be a good electrolytic solution. So distilled water do not have minerals or salts, whereas rainwater contains salt and minerals. So which will dissociate and give ion to pass electricity. Here we can write salts. Once you will put the rainwater in the electrolytic cell, they will dissociate and they will give us ions. So these ions we can use it to pass electricity, whereas in the distilled water it do not have salt or minerals. Now eighth question is, why do acids do not show acidic behavior in absence of water? Earlier we have discussed that when acid comes in a contact with water, then only it will dissociate and it will give ion. The ions are responsible for litmus test. Either it can be a acidic ions or it can be a basic ion. So H plus and OH minus are solely responsible for a change of color in litmus test. If dry acid is there, dry acid gas is there, suppose for example hydrogen chloride gas. So if this gas is there, dry gas, then it will not show any color change on litmus test. So this is the reason that once it will come in a contact with water, then only it will dissociate and it will give us ion. So in absence of water, acids do not dissociate. H plus ions which are responsible for acidic behavior. This is very important. We have to write that H plus ions which are responsible for acidic ions cannot be separated from the molecules to show acidic character. They have to separate, they have to dissociate to show acidic character. Then only it will show the acidic behavior or litmus test. So if it will not come in a contact with water, we cannot see any color change in litmus test or we cannot see any acidic behavior from that acidic compound. Ninth question is, 5 solutions A, B, C, D and E when tested with universal indicator showed pH as 4, 1, 11, 7 and 9. Which solution is neutral, strong alkaline, strong acidic, weak acidic and weak alkaline? So for this we need a pH range. We know that this is pH 1, pH 7, pH 14, where from pH 1 to pH 7 is acidic. As you are going towards 1, it will become strong acid. Here it will become weak acid. This is our neutral solution if it is 7. Then from 7 to 14, this is a basic range. and if you are going towards, when you are going towards 14, it will become strong base, and if you are near to 7 and 8, it is weak base. So now let us see that 4. So here we have A is 4, B is 1, C is 11, D is 7, and E is 9. So let us take 4. 4 is here, so it is acidic. It is acidic. Now we have to choose it is weak acid or strong acid. That we will see later. It is always relative. If this 4 has been given and 5 has been given, then it is, this will become strong acid and 5 will become weak acid. So we have to see that what all pH have been given to us. So 1 is also acidic. Now, so from this 2 we have to decide that which is strong and which is weak. So first is acidic, and as we are going from 7 to 1, it will become stronger and stronger. So this is strong acid. So B is strong acidic. So solution B is strongly acidic. Now 4 is also acidic, but compared to 1 it is weakly acidic. So it is weak. So where is weak acidic? This. So solution A is weakly acidic. Now C is 11. 11 is here. So it is basic. We will write here basic, but we will decide it later whether this is strong or weak. So here it is 7. 7 is obviously neutral solution. So D is neutral. Here we will write D. D is neutral. Now we have pH 9. So here this is 11 and we have pH 9. So 9 is weak basic, whereas 11 is strong basic. So this is strong basic solution, whereas this is weak basic solution. So E is weakly alkaline. So here I will write E, whereas what is left is this strongly alkaline. So it will become that 11 pH. So it is C. So this is how we can decide that whether this is a strong acidic or weak acidic. Now we have to arrange them in increasing order of H plus ion concentration. That means when you are near to 1, the concentration is maximum, and as you are going towards the 14, the concentration will become minimum. So we will start from strong acidic to weak acidic. So strong acidic will be B. So B will come first, then weak acidic will be A, then neutral will come, that is D, then weak basic will come, E, and the last one will be strong basic. So in that the H plus ion concentration will be minimum. And here we have to arrange in increasing order of. So here we have arranged in decreasing order. This is strong acid and this is strong base. So H plus ion is minimum here. And if we want to make it in increasing order of H plus ion concentration, then we will just reverse this order. So C, E, D, A and B. So this in B, maximum H plus ion concentration will be there because it is strong acid. Now next question. Equal length of magnesium ribbon in test tube we have taken A and B. So we have two test tube, that test tube A and test tube B, and in test tube A we have taken HCl acid. In test tube B we have taken CH3COOH. So this is acetic acid, this is hydrochloric acid. Concentration is same for both the acid. In which test tube fizzing occur more vigorously and why? Here comes the concept of strong acid and weak acid. You have to see that which acid is strong. So this acid is strong and this acid is weak. So the concentration of H plus ion here is more and here it is less, because dissociation for HCl is more compared to acetic acid. This concept we have learnt in strength of acid base solution. What all acids are strong are dissociate more and give us H plus ion more. If we are getting more H plus ion, that means the reaction will become faster and easy, and more the magnesium ion will react to H plus. If there are less H plus ion, because weak acids will dissociate less and will give us less H plus ion. So magnesium ribbons Mg. This Mg will get less chance to connect with or to combine with H plus. So if the acid is strong, the reaction will be vigorous and reaction will be at higher rate and it will be faster. Whereas in weak acid, the reaction, the H plus ions concentration is less, so there will be less chance to connect with Mg. So the reaction will be weak and we cannot see a vigorous fizzing in that test tube. So we can see a vigorous fizzing in a test tube A. Why? Because HCl is a strong acid, will dissociate more and will give us more H plus ion. So it will react faster with magnesium ribbon. 11th question is, fresh milk has a pH of 6. How do you think the pH will change as it turns into curd? The fresh milk has a pH of 6. Now we know that our pH range is from 1 to 14. 7 is the neutral pH and our milk's pH is 6. So how do you think the pH will change as it turns into curd? When a milk will turn into curd, it will form a lactic acid. It will contain an acidic substance, so it is likely to go towards acidic side. So when pH of curd will change due to the formation of lactic acid in curd, pH will shift towards acidic side. Earlier it was 6, now it will shift towards pH 1, and either it can be 5 or it can be 4. It is depending upon the sourness of curd. So shift towards the acidic side due to the formation of acidic compound. Now 12. Milkman adds very small amount of baking soda. We know baking soda has basic nature to fresh milk. Why does he shift the pH of fresh milk from 6 to slightly alkaline? So what he will do, that the pH is 6. Now after adding baking soda, it will move towards the alkaline side. So what will happen, that when we want to set this as a curd, or this milk will take a longer time to form an acid, to form lactic acid. So it will not get spoiled in small period of time. So the shelf life of milk will increase when he is adding baking soda. But if you want to make a curd, if you want to set this milk as a curd, then it will take a longer period of time, because what all acid compound will generated through lactic acid will get simultaneously neutralized by this baking soda, because our baking soda is basic in nature. So what is his intention to do this? So that milk will remain fresh for longer period of time, the shelf life of milk will increase. But how it will adversely affect to us, that if we want to make a curd out of this, then it will take longer period of time. So once the pH will shift to alkaline side, it will take longer period of time to set as a curd or to spoil. So it will increase the shelf life of milk. So that's why he will add baking soda, that basic nature substance in the milk, to shift pH towards alkaline side. Now next, why does this curd take longer period of time to set as a curd? As we have discussed earlier, that as this milk contains baking soda, a basic substance, the acid generated by milk will get neutralized by basic baking soda. So it will take longer time to set as a curd. Our 13th question is, plaster of Paris should store in a moisture proof container. Why? We know that plaster of Paris, when it comes in a contact with water, it will become gypsum. It is a solid mass, a solid substance, which cannot be converted back to plaster of Paris. Then the plaster of Paris will become useless to us. We cannot use it further. So it should be stored in a moisture proof container to avoid this chemical reaction. Because when plaster of Paris comes in a contact with water, it will form a hard mass. The chemical reaction will happen and it will form hard mass. So after that we cannot use it. So to avoid this, we have to store this in a moisture proof container. So this is all about question answer from chapter number 2, acid, base and salt. Still you have any doubt, any question or any query, you can write to me or you can comment in a comment box. We'll try to help you out. Subscribe Learn Yourself for more upcoming important videos. I'll see you in next video. Till then, keep learning, keep sharing.